Greetings from Filter Concept. In an attempt to gain a better understanding of the oil and gas industry in detail, we have been exploring various unit processes in the downstream sector of the petroleum industry. To gain further insight into the operations of the downstream oil and gas sector, we will now explore the specifics of crude oil fractionation. In the last episode, we talked about the desalting process. It is a separation as well as a pretreatment process of the crude oil. The desalted oil is sent to the distillation column. The distillation process is a part of the separation stage of the refining process, which we have discussed already in our previous episode. We have gone through few process of the conversion stage of the refining process. Now, let's understand the separation stage briefly. Firstly, the role of separation is to split the feed into simpler or narrower fractions. It is the initial stage of the refining process. The crude oil after extraction is transported to the refineries. It initially goes through the desalting process, after which it enters the fractionation tower. Now, let's delve further into the finer details of the fractionation process of the crude oil. The desalted crude oil goes through the distillation process. It is the process involving the conversion of a liquid into vapor that is later condensed back to liquid form. The process through which petroleum is refined is called fractional distillation or fractionation. Crude oil is a mixture of hydrocarbons. Some very light compounds with more volatility and low boiling points tend to vaporize easily appear in the top product, while extremely heavy and non-volatile compounds appear in the bottom. The petroleum distillation takes place into two steps, one at atmospheric pressure, and the bottom fractionate obtained from this distillation is further sent into vacuum distillation, which is the second step. Vacuum distillation is operated at low pressures and enables recovery of distillate cuts obtained from the atmospheric residue. The side streams separated in the atmospheric distillation column give fractions that include straight-run products which are solely produced by atmospheric distillation and are generally used as intermediate feedstock for further processing within the refining system to increase the yields of lighter products. The residue from the atmospheric distillation column is sent to the vacuum distillation unit, which generates two side streams, light and heavy vacuum gas oils, and vacuum residue from the bottom. The products of the distillation could be classified as top distillates, middle distillates, lower distillates, and residuals. Now let us discuss the products on the basis of aforementioned classification. The light distillates consists of petroleum gases, petrol, and naphtha. The top of the fractionating column gives rise to gases and liquids that have short carbon chains in their composition. While these products are often used as fuels, many have industrial and chemical uses too. The middle distillates consists of paraffin, kerosene, and diesel. Oils below this point have a flash point of higher than 42 Celsius and are classified as fuel oils. The lower distillates consist of lubricating oil, heavy fuel oil, etc. At the bottom extremity of the fractioning tower, the lower distillates form. These have high densities, high boiling points, and are not used as fuels, but more as grease for lubrication. They are formed at higher temperatures of 350 Celsius to 600 Celsius. Bitumen and asphalt make up the residuals. As petroleum products are manufactured to eventually be burned, it's essential that all waste be minimized. So crude oil residue is retrieved from the bottom of the distillation tower, where the temperature reaches 500 Celsius to 600 Celsius, and is put to use. Crude oil fractionation is the most important separation process in the oil and gas industry. It is the foundation for further processing of the valuable components of crude oil into the petroleum products required by consumers. Its importance lies in the fact that it allows the production of high-value products. Its proper functioning directly has an economic impact on the refinery. As a result, any disruption to its operation could potentially have costly consequences. There are a number of challenges faced by the fractionation unit. Trait fouling can reduce the efficiency of the fractionation unit and lead to an increase in energy consumption. Corrosion of the unit can reduce its structural integrity and cause it to fail. Erosion of the trays can reduce the residence time of the product, leading to a decrease in product quality. To guarantee efficient fractionation, the aforementioned issues must be adequately dealt with. Therefore, an effective understanding of their causes and solutions is essential. Fractionation will be more efficient with an optimal filtration solution, which will remove contaminants and improve the performance of the fractionation process. Optimal filtration offers a number of benefits, including improved efficiency, enhanced product quality, and fewer contaminants in the process. Filtration solutions designed by Filter Concept promises to provide superior performance, backed by decades of expertise. Get in touch with us to get your queries resolved at inquiry@theratefilter-concept.com or engg@theratefilter-concept.com. Your feedback will be greatly appreciated. Thank you.